Hey everybody, it's Miss Pollock, and today I'm going to talk to you about velocity time graphs. So this is from your UAPM packet, and this is questions 11 through 14, and I'm going to go through them with you so we can learn a few cool things about graphs. So let's start way kind of at the beginning. We had a position time graph. It was a straight line, and we could find that the slope of that line, which is the change in position over the change in time, is the average velocity. In this case, since the slope is constant, it's also the constant velocity, CVPM, which we did way back at the beginning of school. So let's find the slope of this line. The slope is 4 meters divided by 4 seconds, or 1 meter per second. So that's my average velocity, my constant velocity for this object. So now I can make a velocity time graph. All I would do was draw a horizontal line at 1 meter per second for 4 seconds. Now, both of these graphs show the same motion. One is a position time graph, one is a velocity time graph. I can find the displacement. Remember, the displacement is my final position minus my initial position, the straight line distance between any 2 points. I can find that from my position time graph. Remember, my displacement is my final position minus my initial position. So in this case, that's 4 meters minus 0 meters. So my displacement is 4 meters. Now I can also find the displacement on a velocity time graph. The way I do that is I find the area from the curve to the horizontal x-axis. So I'm going to find this area right here. So that's 1 meter per second times 4 seconds. The cool thing about units is that they, just like numbers, reduce to 1. So seconds divided by seconds is 1. So I end up with my displacement being 4 meters, which is the same as the position time graph, as it should be. Okay, so number 12 is a little bit more complicated in that the object changes direction. For the first 2 seconds, so I can say for 2 seconds, it's moving at 1 meter per second. Then for the next 2 seconds, it's in the negative direction, but it's moving at negative 2 meters per second. All I did was find the slope of those lines. Remember, a positive slope is a positive direction, and a negative slope is a negative direction. So let's draw this on my velocity time graph. For the first 2 seconds, I have positive 1 meter per second, and for the next 2 seconds, I have negative 2 meters per second. All right, so we just learned that to find the displacement, I can find the area. So let's find the area of that part right there. That's 1 meter per second times 2 seconds, so that's 2 meters. Then from the curve to the horizontal x-axis, that is the displacement. So in this case, it's negative 2 meters per second times 2 seconds, or negative 4 seconds. To find the displacement, I take the sum of these. 2 meters minus 4 meters, so my displacement is negative 2 meters. Let's go back to the position time graph. My displacement here is my final position minus my initial position. My final position is 0 meters. My initial position is 2 meters. So I get the same result. My displacement is negative 2 meters. As it should be, because it's the same motion. just represented in different ways. 13, here we have a curved line. We just learned that this means that the velocity is changing. And we also learned that the words for that would be increasing speed in a positive direction. So there's lots of different ways to find the velocity time graph for this. What I did was I drew a line. See my blue line there? My blue line, this right here, my blue line, tangent to the curve at 2 seconds. So I can find the slope at 2 seconds. So, sorry about that. So, at 2 seconds, my slope, my change in position over my change in time is 2 meters minus 0 meters over 3 seconds minus 1 second. So my slope is 1 meter per second. So I know at 2 seconds, the object is moving at 1 meter per second. Okay. All right, my red line right here, that's tangent to the curve at 4 seconds. So I can say at 4 seconds, my slope is, let's go back and look, it's 4 meters minus 0 meters over 4 seconds minus 2 seconds. So my slope of my line there is 2 meters per second. So at 4 seconds, it's moving 2 meters per second. So then I can take a ruler and I can make a straight line. Okay, I know at 0 seconds it's not moving because the slope is 0. So that would be my velocity time graph for that kind of a position time graph. Let's find the displacement. Again, it's from the curve to the horizontal x-axis. So I need to find the area of that. Remember, the area of a triangle is 1/2 base times height. So 1/2, my base is 4 seconds. My height is, oops, sorry about that. My height is 2 meters per second. So my displacement is 4 meters. Let's look at my position time graph. My position time graph, remember my displacement is my final position minus my initial position. 4 meters minus 0 meters. So my displacement is 4 meters. So again, my displacement is the same. It's the same motion, different representations. All right, the last question, question 14, really important. Both the slope and the area of graphs have physical meanings. The slope of a position time graph, I said that lots of times. I hope that's in your brain. That tells you the average velocity. The velocity time graph, it says determine the units for a square. Okay, so if I look at one of those squares, vertically it's 1 meter per second and horizontally it was 1 second. So 1 meter per second times 1 second. Remember, units are like numbers. They can reduce to 1. Seconds divided by seconds equals 1. So each square is 1 meter. The area under the velocity time graph from the graph to the horizontal axis tells you, tells you the displacement of the object. Yay! Great! Have a great sunny day!